Boom. I think we're going. All right,
Awesome.
cool. Yeah. So, hey, this is Jacob Tucker and Andrea here. This is going to be our first video. It's a contract review series where we are going to be basically going over some of the contracts in the Flow ecosystem and explaining them. So, with that, Andrea, if you'd like to introduce yourself, feel free to.
Yeah, hey, hi everyone. My name is Andrea Mutoni. I recently joined the Flow team as a developer advocate. And yeah, I reached out to Jacob because I heard he was a cadence virtuoso, as I like to call him. And I feel like there's a lot of interesting contracts being created in the community. So having, maybe a series where we can look at the most interesting ones and maybe also invite the authors of those interesting contracts to come and speak and explain their reason, explain the peculiarities of their contracts could make for an interesting series and also a good learning opportunity. So that's
Awesome.
the context.
Yeah, yeah, awesome. Yeah, so Cadence God, Cadence Wizard, Cadence Beast, I've heard it all. We're here to, deliver the best content we can. And with that, we're going to be starting with the non-fungible token standard on Flow. So this is sort of like the go-to, you want to start learning cadence development. The non-fungible token's the way to go. People love NFTs, they love their profile pictures. So let's get going and learn how we can actually, make our own NFTs on Flow. So what we're
Right.
looking at right now is basically, actually, I mean, I guess we could even explain what an NFT is if we wanted to, right? So Andrea, do you want to, explain what you think an NFT is?
Yeah, sure. It'd be interesting to hear both of our perspectives.
Yeah, yeah,
So I see, okay, so there's a fungible token and there's a non-fungible token,
yep,
right?
yep.
And those aren't just fancy words. A fungible token is something that can be exchanged for a token just like it.
Hmm.
For example, a unit of currency, right? And it doesn't matter which unit of currency you use to make an exchange, any of the ones that you have can be used and they are interchangeable, right?
Yep,
So if I have, let's say, $100 and I give you 10, whichever 10 I take from my pool of $100 does not matter.
yep.
And if I take 10 and I give it to you, and then you use those 10 to buy something else, they will have the exact same value and the exact same fungibility.
Hmm.
Hence the name fungible token.
Yeah,
Whereas a non-fungible token really, I mean, right now it's become like it's become synonymous with art, profile picture projects, but really non-fungible token is so much more than that. Because if you think about it, most things in the world are non-fungible. A car on the street is not perfectly interchangeable with another car on the street.
hmm.
A house, a computer monitor, a glass. I'm just looking at things that I have in my room. A
Yeah.
plant.
Plants. My
All of these
desk.
things are non-fungible because they are unique and distinct in some way. Even if they are, let's take the example of this glass, right?
Yeah,
Even if this glass was made in a batch of a million, right?
yeah.
This specific glass has a history to it, has usage, maybe has a couple imperfections that make it unique. And it's not perfectly interchangeable with brand new glass at the store,
Yep.
right? So the reason why it's non-fungible is because once you have that thing, which we represent via a token, it is unique in some way. That's
Exactly.
my interpretation of non-fungible token. But Jacob, I'd love to hear yours
Yeah,
as
I
well.
mean, it's funny. I was literally going to say that as well. So like, I would explain it again, but I think you actually said it perfectly, right? So like the non-fungible token is like something that can't be interchanged, where a fungible token is people like to refer to like U.S. dollars, for example, right? If I give you a dollar, then it's the same as someone else giving you a dollar. So I think what you said is perfect, and I actually want to leave it at that, so I don't mess it up. So great, that's a great explanation. Thank you, Andrea. Yeah. So what we're looking at is basically a non-fungible token standard, and what does that mean in the context of the blockchain? Well, standards are really crucial for deciding which NFTs are official. And what I mean by that is, if you go to like OpenSea, for example, that's like the most popular, marketplace on the blockchain. Every NFT that you buy on there fits the NFT standard. And the NFT standard means it has to have a name, it has to have like a link to some metadata, stuff like that, maybe like a unique ID. And the reason that a standard is so important is to make sure that the NFTs you're buying actually fit some sort of like requirements to be able to be displayable and all that kind of stuff. So that's why we're really looking at the standard today is how do you make an NFT that, not only represents art and stuff like that, but how do we make it basically available for any platform on Flow to be able to use them? So they have to really abide by the standard here. So in order to do that, we have the NFT contract on the left. So this is the standard. And on the right side, we have an example implementation of an NFT. So, when we're looking at this, so this is like the first video on our contract review. So we're going to be explaining some of the cadence concepts as we go along here. And the first thing to look at is the difference in this first line. So a contract interface, and on this side, it's a contract. Now, what's the difference between that? Well, a contract interface is basically a set of requirements. And a contract is basically something else that implements those requirements. So we can see that on the right-hand side, our example NFT contract is implementing the non-fungible token requirements. So this contract has to make sure it has all the stuff in this contract interface. So that's sort of where, that's sort of the difference between the interface and the contract itself. All right. So what that means is that we're going to basically go through the non-fungible token contract, and we're going to look at all the things it's telling us we need and see how we put it on the right-hand side. Does that make sense so far, Andrea?
Yeah, absolutely. Maybe one thing I'll just add is, a couple of days ago, we officially, as a community, we officially kind of came to the how do I put this? Exactly, yes.
Yeah.
We came to an agreement on a Nft Metadata Standard, right? Which should be seen as an extension of this base non-fungible token contract interface. So perhaps we'll do a video in the not too distant future covering that in detail. So the only reason I'm saying this is don't focus too much on the implementation details of the example NFT, right? Especially on the metadata side. So line 18 on the code on the right. And we'll just focus on the foundations of what an NFT is beyond the metadata.
Yeah, that's very important to mention, because there's actually going to be, as some of you may know, the cadence language is still in its very early phases. It hasn't even reached V1 yet. So there's going to be a ton of changes that come to that. The cadence language, but as the changes come out, we will review all of it and do all that kind of stuff. So just like Andrea said, don't focus too much on the metadata. There's a lot of cool things coming on that will be reviewed in a couple of weeks even. So let's just go over some of the base stuff. So the first thing we have here is a total supply. So this is sort of a variable that keeps track of the total amount of NFTs that have been minted. So you can see on the right hand side, boom, we have the total supply. So that's pretty simple so far. Then we have some events here, like a contract initialized, a withdraw event, a deposit event, and we're gonna get into these two in a bit. But the contract initialized is just an event that gets basically emitted when the contract is deployed. And so you can see down here in the init function of our example, contract, we emit the contract initialized when it gets deployed. So that's covered. Now we're going to start getting into some of the core things of an NFT standard. What are the things you need to have? Well, the biggest part, arguably, is the NFT itself. And this is why cadence is so beneficial, is because the NFTs are represented as resources, which is a really crucial type to, basically have security around your NFTs, have readability around your NFTs, all the stuff that cadence supports that languages like Solidity don't. Right, in Solidity, for those of you that have coded in Solidity, your NFTs are represented just by a number, which is kind of weird. In this case, NFTs are represented by a resource, which there can only ever be one resource, right? You can't copy a resource, which is exactly what NFTs say as well. And, you can't destroy a resource very easily unless you explicitly do it. And so that's really important.
You can't lose it.
You can't lose it, exactly. And that's really important because if I have like a $2 billion Bored Ape, I don't want to lose that. I want that forever. And so I want it to be very hard to destroy that. And that's why resources really come into play here.
I think it's worth spending just 30 more seconds on resources. So as you were saying, just to reiterate how risky Solidity development is, every asset, every token that gets created in an Ethereum contract is stored in the contract itself, right?
Yep.
And for those of you who are programmers, it's stored in a big, key value map, right? Where as the key you have who owns it, and the value is the actual resource, or I think it's the other way around. Anyways, it's a big key value map.
Yeah.
Whereas with resources and how Flow works is a resource, given that it can only exist and either be moved or explicitly destroyed. And you have to create a special command to destroy it.
Yep.
Where it gets moved to is to someone's account, right? And the storage model on Flow is very important to understand. So anything we create on Flow through Cadence and smart contracts is stored somewhere, and it's not stored in the contract itself. It's stored. It can be stored in the contract itself, but
Yeah.
usually, if you buy something, if you own something, it gets stored in your account, which is a lot more reasonable and a lot more in line with what we think is decentralized,
Yep.
right?
So true.
And
Yeah,
we'll
right.
look at
Like,
that later.
so true, right? Like users have like ownership over their assets. The contract isn't controlling
Exactly.
your data. You have this in your account. You can move it whenever you want to. You have complete ownership over your assets. So such a good point by Andrea there. And that's why resources are so crucial to the Cadence language and NFTs in general. If we sort of continue here, the next bit, we're going to skip this for now. We're going to come back to these. These are all resource interfaces, and I'll explain those in a bit. But the next biggest part is the collection resource. So on Flow, what Andrea was mentioning earlier was, account storage, right? But you can only store one thing at a specific path in your account storage. And that's a little confusing. So what do I mean by that? Well, on Flow, accounts have these things called paths, and you store data at those paths, but you can only store one thing, right? So you can't overwrite it. You can't store multiple things there. You can only store one. So the issue with that is if we want to store NFTs in our account, we would have to store every NFT at a different path. And that's not great because then things get lost and it's hard to remember where you store them and stuff like that. So instead, we're going to use a collection. So what we can do is we can put our collection at one storage path so we know exactly where it is, and we'll put all of our NFTs in that collection. So it's really helpful, and it's a sort of like central point for all of our NFTs in our collection. And you can see that happen on the right-hand side here. We have a collection, and it stores all the NFTs that we want in our collection. Now, this is where sort of cadence types get a little confusing, is because you'll notice that it says non-fungible token.nft. Well, why is it saying that? On the right-hand side, it just says we're going to map some sort of integer to an NFT. Well, the reason for that is because when your contract implements a contract interface or a spec or like a standard, I guess, you have to make sure that the types are the same. And in Cadence, types are based on the contract name and where that contract lies. So in this example, owned NFTs is referring to the NFT that's defined that has the ID and all this kind of fun stuff. And so on the right-hand side, when we actually implement this standard, this type is actually the same as this type because it's referring to the NFT that's defined in this contract. So that's
Right.
where that sort of ties in. Yeah.
Exactly. And if you go to line 1 on the file on the right, you'll see it be imported. And that's why we can access non-fungible token.nft because we import it from this other file, right? So
Exactly.
this opens another important term. And sorry if I'm like the guy who
No.
pulls the brakes, but this is exactly why smart contract development is cool. And it's because I can import this contract on my own stuff and I can build on the example NFT and import that in my own code and create something that's based on an existing contract. And this concept of composability means that if everyone pulls from standard contracts, it makes everything a lot more interoperable and everything is API-able in a way, right? And that's the beauty of the blockchain is everything is composable because everything is importable.
Yeah, no, yeah, and also keep interrupting me because everything you're saying is really helpful. I'm sure to everyone that's listening. That's so true, right? The reason that we can actually say non-fungible token to NFT is because we import it, right? And there's so many things you can do with that, right? We can import this in any contract that we want. So yeah, that's really great. So as you can see in our collection, we're mapping an integer to the NFT resource itself. Now the integer that we're going to use is the ID of the NFT. So if we scroll back up here, you'll notice that the NFT has an ID in it. We're going to use that ID to actually store it in our collection. So if we say, hey, we want to look at, an NFT with ID 5, it'll map 5 to that NFT that has that ID, right? And then there's some functions inside this resource. So there's a withdrawal function, there's a deposit function. These are ways of putting NFTs in and out of our collection. So on the right-hand side here, you can see that the withdrawal function takes in actually let's do deposit first because we'll sort of like follow the pattern here. So deposit takes in a token And remember, look at the type here again. So it says on the left-hand side, it takes in a token that's of type NFT. We want to make sure the type is the same, so we refer to the one that we're sort of implementing here. So we're gonna get this token. We're gonna make sure it's of the specific type that we want. So we're gonna make sure that this token type is actually the example NFT.NFT, not some like random crypto poop.NFT, right? This actually has to be the one that we want, and then we'll get the ID from it. So token.id. That's simply just this field right here. So getting the NFT's ID, and then what we will do is we will store it inside of owned NFTs. So we're going to move this token that we defined right here into self.owned NFTs at ID, and then it will be inside of our dictionary right here. Now, it may look a little confusing because we're also moving out an old token. This is just Cadence syntax. Essentially, part of resources is that you have to make sure that there's no other resource in there, because remember, you can't overwrite resources. That's why they're so important. So what we do is we use this syntax to move out any old token that would be there, which will never happen because no two NFTs will ever have the same ID. Hence, Andrea's description of non-fungible token. But we do this just to make sure that this compiles and it's all fine. And then we emit a deposit, event to say we deposited.
And I think it's worth for those who are relatively new to Cadence to explain all the weird symbols, right?
Yeah.
Because the cool thing about Cadence is that it's very readable, but there are a couple symbols that are specific to Cadence, and it's worth just like clarifying what they do.
Yeah.
And the first one is the lower than hyphen. Okay, actually, let's go in order. Let's go with the at.
Yeah.
Right?
Yeah, so what the at means is this is a resource type. So when you take in something that has this little at thing in front of it and then a name, that means you're taking in a resource. And that means that there's a lot of restrictions that come with that. Namely, you have to move your resources around using the move operator. So when we move this resource into like a dictionary, we can't just say equals, because if we say equals, it's going to say you can't do that. We don't, there could be something else there. You're going to lose the resource. Bunch of errors. In order to get rid of that, you would use the move operator to say, we want to explicitly move our resource to this location, and that's so important, and a lot of the security around resources is because of this move operator. Yeah.
And it's important to know that the move operator is specific to resources. So wherever you see the move operator, you're dealing with a resource. Whenever you see the at symbol, you're dealing with a resource. And just, I'm going to err on the side of like over explaining versus under explaining.
Yeah.
So just to reiterate, a resource can only be created, can only be moved via the move operator, or it can only be destroyed. Those are like the three life cycle actions that can be done on a resource. It can't be copied, and you can't forget to do something with it in a function, because Cadence, when it comes time to running the contract, would just panic and it wouldn't lose anything. So also another cool thing about Cadence is that if at any point of the contract something wrong happens, everything is canceled.
Yep.
So It's not like you're like halfway through a transaction and you gave someone some money and then something happens and you're like, oh wait, but I didn't get the stuff back. No, that never happens. Everything succeeds or nothing succeeds.
Yep, exactly. So just to sort of build on that point, right? Like if we had this deposit function and it was an empty function like this, Cadence would say, nope, you can't do that because you're losing it. The error message would literally be loss of resource, and that's because we aren't putting this resource anywhere. So like Andrea said, we have to explicitly move that resource into a location, and then it will be okay with it. So boom, that's it. Now, so also to explain some of the other sort of symbols here. So I already explained this move operator, right? So that's just, like that. But this symbol right here, the exclamation mark, what the heck does as exclamation mark mean? Well, what this means is we're taking in a generic non-fungible token NFT, right? So this is basically saying we're taking in any NFT that abides by the spec. So this could be a Jacob token, this could be Andrea token, this could be crypto poop, this could be Bored Ape, it could be literally anything. But what we want to make sure is that we only want to store tokens that are, that are, these NFTs right here, example NFT.NFTs inside our collection. Right. And so what we do is we make sure of that by saying, let's take our token and let's typecast it, or force cast it is what they call, by doing as exclamation mark to at example NFT.NFT. And this says we want to make sure that this token is the type that we want. And if it's not, panic, which is what this little exclamation mark does. It says, nope, throw a panic, start screaming, and then it'll revert everything. And like Andrea said, if we had like deposited some tokens or given someone money, doesn't matter because when we panic, it's going to revert everything. So everything goes back to its original state. So that's what this is doing right here.
Yeah, and we're starting to see why Cadence, is perfect for smart contract development because it was built for smart contract development.
Exactly, right? Yeah.
Yeah.
Yeah. It's yeah.
Yeah. And yeah, sorry. And so just a minor note on the exclamation mark. So the exclamation mark is force, right? And in this case, it's applied to casting, so as exclamation mark, but it can be applied to other stuff, and we'll look at it later when we do come across it. I don't want to, add more stuff on the pan unless we need to.
Yep.
But just remember that as exclamation mark is not a thing that only exists and that's it. It's as is a way to cast something to a specific type, and we're forcing it, and we can force other stuff in Cadence, and we'll see how in the future.
Exactly, right? So namely when we start talking about optionals, that's when this is going to be so important, and we'll get into that in a bit.
Yeah.
So this, I think, Andrea, I think we've wrapped up everything in this function. Is that right? Or are there other things we can go over?
Yeah, maybe. Yeah, I think you already walked through what's happening. So yeah, and maybe the only thing left to say is on line 54.
This.
When we declare events at the top of the contract, we then use them wherever they're relevant to be used, right? And in this case, we're emitting the deposit event when something has been deposited. So people can listen to that event, right? And do something. For example, if we have an app that is showing or notifying people when there's a deposit event, it can latch onto it and do it. So it's pretty self-explanatory, but just want to say that at the top, we're declaring that these events exist. And within the contract, we then emit those events.
Exactly, right? So we declare it here. The event, it takes in two parameters, an ID of the NFT and a to, so who we depositing to. And then down here, this is exactly what we do. In the deposit function, we deposit the ID, the ID of the NFT and to self. Okay, so this might be worth explaining. Self.owner.address. What does this mean? Well, self is a keyword that refers to the thing, right? That's vague on purpose, right above it. So what this means is self is referring to the collection because it's inside of the collection. And self.owner basically returns the owner of this resource. So whoever has this resource in their account storage, it will be that person. And then .address, it simply gets their address. And we will get into optionals in a bit, but just to sort of go over it a little bit, the reason we have to put this little question mark here is because the event is specifying it wants an optional address type, which means it's either an address or it's nil. And what this question mark down here is doing is it's saying, okay, let's get self.owner and let's make it an optional type so that when we do .address, if the address exists, give it the address. But if the owner doesn't exist, return nil. And so that's exactly what the optional is doing there. All right. Yeah. So then let's go into the withdraw function. This is going to be, so we understand some of the syntax now, but we're going to be withdrawing. We're going to pass in an ID, and it's going to return a NFT type. What we're going to do is we're going to take the token with that ID out of the owned NFTs dictionary. The way to do that is to say, okay, where's the NFT? Well, it's self.ownnfts.remove the key that is withdraw ID here. So we're going to remove the NFT with that ID. And what this is saying is this is really important in Cadence code. So the panic. What this is saying is, okay, we want to remove this NFT, but if it doesn't exist in the dictionary, then we're going to have these two little question marks here, which means if it doesn't exist, panic. And what a panic does is it reverts everything and it doesn't exist. And nothing in the transaction ever happened. Abort. Yeah. Just run away as fast as we can. Abort. That's what that's doing. And then we're going to move that NFT into this token variable here. All right. Then we're going to emit the withdraw function. Literally, it's exactly the same as what we saw below. And then we're going to move. Remember the move keyword. We can't just say return token. We have to explicitly move it outside to the function. So that's what that's doing right there. All right. Then there's some other cool functions we can use like get IDs. This just returns self.ownnfts.keys. So it returns an array of all the NFT IDs. And borrow NFT is also cool because it takes an ID that we want to borrow from and it returns a reference to the NFT. So it doesn't move the NFT out of the collection, but it returns a reference to it so we can read stuff like its ID. And so it's going to return a reference to a non-fungible token. We know on the left-hand side that an NFT is a ID field here. So all we can do with this reference is read its ID field. That's pretty much all we can do with it.
And we can read it because it's public, right?
Yep, exactly.
Yeah, and so pub means public, and there's also another way to write it, which is like access parentheses all, and there's different access levels. Again, we won't look into things unless we come across them, so that we're only like digesting a little bit at a time. But it's worth knowing the broader context.
Yep.
And maybe one thing to note here is the difference between a return declaration on line 66 versus an implementation on the resource a bit further up, because they're using the same syntax, right? So colon and something. So in a function, everything that comes after the colon is what type we're returning or what types we're returning, right?
Yeah.
Whereas on the if you scroll up a little bit, when we declare a resource, for example, that's what we're implementing, right?
Yep. Exactly. So you're talking about this right here, right?
Exactly. Yeah.
Yeah.
Or also the contract itself, right? Like we are implementing a So
exactly.
Do you want to talk about it?
Yeah, sure. Yeah. So exactly right. So the colon has a lot of different meanings. One of which, actually the most simple version of this, is declaring what type a variable is. So if we look at like public let ID, we do colon type. That's saying this variable has type UN64, which is just an integer, right? That's unsigned. But in the case of like a resource, for example, the resource can have colon and then a resource interface. Now, a resource interface is basically saying this resource has to implement this interface. Now, we can actually look at this interface. Let's go to the left-hand side here. And so we can see public resource interface INFT. That's a resource interface saying, okay, whatever implements this thing must have an ID. And so that's what's going on over here. It's saying, okay, it's implementing this. It must have an ID, which it does. Boom. So this part of the video was cut out because I screwed up the audio, but we're back in action. You'll probably notice that because it's pitch black out for me right now, and I was wearing something completely different. Yeah, that's bright morning for Andrea. But we're back again on line 66 here. So we're looking at the borrow NFT function now. And what I wanted to mention was this little reference symbol. So in Cadence, the reference symbol is this little and. And so if you see that like in front of something, that means that you're basically dealing with references. Now, in Cadence, whenever you're dealing with a reference, you have to typecast it, or Cadence is going to say to you, hey, we don't really know what this reference is doing. You have to typecast it to something. And so here, because we're returning a reference to a non-fungible token.nft, we typecast it by saying at self.owned.nfts at ID as this type. And so that's sort of like a typecast, and you have to do that. All right, cool. Now, the last thing we're going to...
And maybe, Jacob, one thing that would be cool to get into is, what's the difference between, like, when should I use a reference and when should I use the actual resource?
That's a great question. So the great thing about references is that you don't have to move resources back and forth. So remember we were talking about with resources, you have to explicitly move them out, do something with it, and then move it back in. That would be super annoying, right? Because if we wanted to just read the ID field of an NFT, we would have to move it all the way out, read it, move it all the way back in. With a reference, we can simply just say, hey, let's get like a nice reference to it and just return the reference. So we never have to move the actual resource. So that's where it gets really helpful. Now, I will mention that like with stuff like integers and strings, this never makes sense, right? Because you would just return the string. But it's helpful with resources. You don't actually have to move the resource. So the last thing here is the destroy function. So the destroy function basically says, hey, we're destroying self.owned NFTs. And the reason we have to do this is because when you have resources inside of other resources, you have to tell Cadence how to, and so you can see we have a resource collection and we have owned NFTs inside of it. So we have to, explicitly destroy it here. Awesome.
Because again, in Cadence, you can't lose any resources. And since this resource is containing other resources, there needs to be a way to manage that life cycle when you're destroying the parent resource.
Exactly. So the part that we skipped over before was these little resource interfaces here. So what do these mean? Well, these are just restrictions on the collection resource. So it's basically saying this collection resource must implement the things that are in these three. And we can actually go and view them on the left-hand side here. And we already went over what all these functions do, right? So the provider says we need to have a withdrawal function. The receiver says we need to have a deposit function. And the collection public says we need to have, a deposit, get IDs, and borrow NFT. Now, why do we do this? Well, what's the point of these? Well, they basically allow us to read our collection in different formats. So one example of this is if we want to actually allow people to read from our collection, we would expose the collection public resource interface so they could deposit, get IDs, and borrow NFTs. but we would never want to, expose something like the withdrawal function, which is the provider resource interface. And we'll see an example of this below when we actually link our collection to the public, but it's sort of a way of categorizing how we expose our collection. Another thing to mention here is pre and post conditions. So we'll get into this when the time comes around, but it's sort of helpful to go over it here. A post condition is something that runs after a function ends. So after we, on the right-hand side here, after we do all of this stuff, it's going to run this post condition that says, hey, we want to make sure that the result, which is a keyword for whatever value is returned, which is an NFT in this case, the result NFT's ID is equal to the ID that we, requested. And this is basically ensuring that, we don't have like a malactor here who is returning an NFT with ID 4 when we ask for it. So that's sort of like an extra requirement that we're checking. And if that's not the case, it will panic. And as we mentioned before, panicking will just revert everything. We'll scream and shout and it'll all be, back to its normal state.
Right.
All right.
And one thing that's worth mentioning is that these three interfaces, right? As you said, they're a way to modularize the access control, and they're completely arbitrary, meaning that when you're writing your smart contract, you can decide how to split up access, and some accesses can overlap with each other. But the important thing is you want to make it so that you have different plugs into your resources and into your smart contract that reflect the minimum required permissions to actually do something.
Yep.
You don't want to give full access to someone. For example, you don't want anyone to be able to mint an NFT. You just want to be able to read from the NFT, right?
Exactly. Yep.
So
exactly.
that's just how it's split up here, but you don't have to follow this exact pattern if it doesn't fit your use case.
100%. Yep. So, for example, just building off that, if we wanted to expose something to the public, but we didn't want to allow them to deposit, we could simply just get rid of this and then expose this new one to the public, and then they would only be able to get IDs and borrow NFTs. So it's really a great way of, like Andrea said, like categorizing, what we want to do.
Right.
So then, in Cadence, you can only create resources inside of the contract itself. So in order to allow people to actually have this NFT collection, we have to have a public function called create empty collection. And what this does is basically allows anyone to call it, and we're going to use this create keyword to actually return a new, collection resource. And so we'll return it. It's of type NonFungibleToken.collection, and now they can store that in their own storage and stuff like that. And we'll see that below. But Andrea, before I actually had this whole audio debacle, you had actually touched upon, the difference between pub and other stuff like access contract, if you wanted to sort of mention that again.
Yeah. So when you see pub, it's not just going to grab a beer at a pub. It actually means public. And sorry for that joke.
I like it.
But you can determine what parts of your code have what type of access, right? A synonym for pub is access and in parentheses all, right? And there's different access levels. It can be private, it can be contract. Anything that's public can be publicly accessible. But as Jacob said, resources can only be accessed within the contract itself. So even though they're public, you can't really access any of the methods of the resource unless there's a function that exposes them.
Yep.
Such as create an empty collection. And that way you're guaranteed that have methods that are public that seem unsafe, but you don't need to worry about it because only the contract itself has access to those.
Yep, exactly. And so that's why in this case, we're returning an empty collection here with the public modifier so that anyone can, get this collection for themselves. So one example of this is actually below inside the contracts, and you'll notice that this account, right? So in Cadence, contracts are deployed to accounts. This account that's actually, that's holding this contract is actually storing its own collection right here. So it's doing let collection, the little move operator, and it's creating an empty collection. Now this is the same exact thing. It's just doing, if we wanted to say like example NFT dot create empty collection here, because this is what you'll be doing in the transaction, right? Is calling to create empty collection. It'll return a collection resource, store it in this variable, and then boom, we do account.save and move it into our account storage at this specific path. So it might be worth getting into paths for a second. Andrea, if you wanted to introduce that.
Yeah, sure. So paths are exactly like Jacob mentioned at the beginning, which is, it's essentially like a folder structure, right? Where within a folder you can store things. However, in Cadence, only one thing can be stored in a specific end folder. And usually paths are split up into two parts. The first part of the path, so you see where on line 105 it says storage, on line 109 it says public. These are fixed, and there's three types. There's storage, public, and private.
Yep.
Right?
Yep. Private.
And And those are, I forget the proper term for it, but those are like the domains. Whereas the second part of the path is completely arbitrary. And in this case, we're calling it NFT collection, right? But this is the location that we decide within that domain to store specific resource. And as Jacob mentioned, but it's worth reiterating, we can only store one thing in each path location. That's why we need to have a resource which represents a single thing that contains multiple resources, such as the NFTs, right? And that's why we store the collection in a specific path. And within that, we can store the NFTs. And one way I like to look at it is, if you've ever played Minecraft, is the second part of that path is like a chest, right? And you only have space for one chest, but within that chest, you can make it so that you can store other things.
Yeah, Minecraft is my my favorite game ever, so I would love more Minecraft references. But yeah, it's exactly what Andrea said, right? So, you know, the storage path is saying only our account can ever mess with this. So we're putting our collection in a very secure, you know, safe here. No one can ever access this except for us, which is why when we want people to be able to deposit, get IDs, and borrow NFTs, you know, just borrow a reference, like read, you know, an NFT's ID field, we need to explicitly allow the public to do that. And that's why we do self.account.link, which creates something called a capability. And the capability says you can take this thing, you can put it to the public with certain restrictions that you decide. So you'll see here, it's looking, the target is the storage NFT collection, which is where we put it. We're going to link it to /public. You know, this is a new sort of like chest or a new domain. And this is, you know, to NFT collection. And we're going to say, you know what, we're going to put this restriction on it. So these little curly braces here, these are restrictions on your resources. And specifically, everything inside curly braces is always a resource interface. So, you know, when we do this thing, this is saying, okay, we're going to link a reference to a resource that is restricted to the non-fungible token.collection public type. So that's saying when we link this to the public, the person that goes to this path name can only do these three things, which is deposit, get IDs, and borrow NFT.
Right.
And this is,
sorry, no, I'll let you finish first.
Oh yeah, I was basically just gonna say, like, you know, if we had something, you know, some of you may be wondering, well, you know, could we also do something like this where we say, you know, we're gonna link a non-fungible token dot collection. So this was one thing that tripped me up when I was first starting Cadence was, well, what's the difference between what we had before and this? Well, these are actually the same exact, because this is a reference to a non-fungible token collection that's restricted to this resource interface, which is the exact same thing as just saying this, because they expose the same three functions. This, you know, either way.
Yeah, that was exactly what I was going to say. So really, that reference is referencing anything that follows the restrictions within the curly braces, and that's why this shorthand is equivalent. Because really, what we care about is the restriction there.
Exactly. So now that we've sort of dealt with our collection, you know, the only other thing to really talk about is, well, how did the NFTs get created, right? Because we just mentioned that that NFTs or resources in Cadence can only be created in the contract. So we need someone that can actually do that creation. And that's with an NFT Mentor Resource. So this NFT Mentor Resource contains one function, which is mint NFT, and it takes in one parameter, which is a recipient. And that recipient is a type that is a reference restricted to non-fungible token.collection public. And the reason for this is because when we call this function mint NFT, we want to deposit a new NFT into someone's collection. And it's really helpful if we can access the deposit function of someone's collection in order to do that. And so you can see that by making this type reference to a non-fungible token.collection public, we can call this deposit function on it on the left-hand side here. And we do that exactly on line 93, where we see recipient.deposit, and we pass in a new NFT. So this is really just calling, if we go to above, this deposit function inside the collection. That's all it's doing. And you'll notice it takes in a collection, which is an NFT resource. So if we go back down here, you know, we create the NFT, we store it inside of a variable here, and then we pass it into the deposit function, and boom, it's now in that person's NFT collection. And then after we do that, you know, we simply just, you know, do example NFT.total supply, and we increment the total supply just for, you know, just in order to like make sure that we're keeping track of the amount of NFTs that we have minted. So one other thing that I will mention is that I think because of this audio cut, you know, we had sort of before, you know, we were using like the total supply to actually give IDs to a certain NFT, because, you know, you can sort of like configure it where, you know, if you increment the total supply every single time you mint an NFT, well, then, you know, the next NFT's ID can just be the total supply, you know, 0, 1, 2, 3, 4, you increment it upwards. But what's actually a better way to do this is to just use a UUID. And a UUID is a unique identifier that's associated with every resource on Flow, and no resource ever has the same UUID. So it's actually much easier to make the ID of our NFT be its UUID because they will never be the same.
And it's a lot safer.
It's a lot safer. Yeah, exactly. All right. So, now that we have an NFT minter, we need to give this to somebody, and we don't want to do that like we did with collection, because if we had a function here, public function, create minter, well, this would be pretty bad, right? Because then anyone would be able to call into the contract and return a minter. So we don't want this to happen because then anyone can mint NFTs. What we do instead is we only allow in this init function, this account to store an NFT minter, and we do that here. We say let minter, we create the minter, and we store that to account storage. And then this way, this account is the only account that will ever have the minter. And, if they wanted to, they could just give it to somebody else. But, there's only one NFT minter that will ever exist.
Right. And one thing worth mentioning here is that some contracts have the concept of administrator, or they create roles that have capabilities that are a little bit more elevated in privileges with respect to just anyone importing the contract. Right. So if we wanted to, we could create an admin role that has the capability of creating an NFT minter.
Yep.
Right. And that way you can give multiple accounts the administrator role and they have a little bit more control. But this contract specifically doesn't have that, and you don't have to have that. But, really you can create whatever you want, and you can create the access levels that you want. Yeah. Creating resources that have access to this resource and exposing them via capabilities.
Yep, I'm so glad you mentioned that. So what Andrea is talking about is an example where, you maybe have like another resource here called admin. And in this admin resource, you have a function that says like, create minter. And so what you do here is you would store this admin inside this account, but, that admin could then distribute minters to whoever they wanted to. And so, you sort of have a different minting system there, but it really is up to you to decide how you want to mint your NFTs. So yeah, I think that wraps up our contract review. Thank you so much, Andrea, for doing this with me. This is the second time we've said this because we got it off
yeah,
the first
and we're
time.
like forgetting what we said and
Yeah,
what we didn't say.
Yeah, we're really trying our best here. But anyway, yeah. So
and P.S. It's like 5 a.m. where Jacob is. So
yeah.
Big props to you for staying awake and and having such a being able to follow a stream of thought.
Yeah, my camera on my screen is covering the time, but I'm moving my camera so you can see 4:47 in the bottom right screen of my computer. So there it is.
What a legend.
Oh yeah, but anyway, yeah.
Yeah, and one thing we did mention in the previous take was that we're looking forward to creating many more videos. So we started with this simple base NFT contract and its corresponding interface, but hopefully, once the metadata is rolled out, it has been rolled out, but once it's been announced properly and we take some time to study it, we can create a video on that and maybe invite some of the people that were critical in creating that standard, which were all community members. It was an effort on FlipFest. And then review as many interesting contracts from the community as possible and have their respective authors come in and talk about it. I think that would be super cool.
Yep, I'm super excited for that. One example of that's probably going to be BRTech and the Versus platform we'll have up next. So I'm really excited for that. And find. Yeah. So there's tons of stuff to do. We might be on episode 100 at some point, but this is episode 1.
Damn,
We're excited for the future. And thanks everyone for tuning in, and happy holidays.
Bye.
One thing I forgot to mention is that all the contracts that we just reviewed, the non-fungible token standard and the example NFT, are actually on the Flow GitHub. So if you go to github.com/onflow/flownft, which would take you here, and then you click on contracts, and then you would see the two contracts that we just went over are literally right here. So you can go ahead and view them if you'd like to. And if you want to start messing around with them, if you want to, actually start changing some stuff about them, you can feel free to go to a Flow playground and copy and paste them into here, and you can start messing around with those contracts as well. So just wanted to mention that. Okay, bye for real this time.